Alright, so now we're going to do parent function for cosecant. So cosecant is the reciprocal of sine. So three terms that my students always get confused are opposite, reciprocal, and inverse. Okay, cosecant is the reciprocal of sine. Okay, which means that in a reciprocal you take the numerator and the denominator and you switch them. Okay, or like students love to say, you flip them. Okay, so to find cosecant values, you got to start with sine. So here we go. Just like when we did cotangent and tangent, when we plug in 0 for x into sine, we get 0. When we take the reciprocal, that's like 1 over sine x. So if sine x is 0, this is 1 over 0, which means here cosecant is undefined. Okay? Now, same thing for pi over 6. Sine is 1/2. The reciprocal of 1/2 is 2. So I'm going to write this is undefined. So pi over 6, 2. Then the reciprocal of 1 is still 1. So this is pi over 2, 1. The reciprocal of 1/2 is 2. So 5 pi over 6, 2. The reciprocal of 0 is undefined. The reciprocal of negative 1/2 is negative 2. The reciprocal of negative 1 is 1. So 7 pi over 6, negative 2, and 3 pi over 2, negative 1. And this is negative 2 and undefined. So just like tangent and cotangent, cosecant has asymptotes. So that's where I'm going to start. So we have asymptotes at 0, at pi, and at 2 pi. Okay. Then we have the points pi over 6, 1/2, which is, pi over 6, 2, which is here. Then at pi over 2, we're at 1. Then at 5 pi over 6, we are back at 2. Then at 7 pi over 6, we're at negative 2. 3 pi over 2, negative 1. 11 pi over 6 is at negative 2. And it looks like this. So again, using kind of our idea from rationals, we don't have an x-intercept here. There are no x-intercepts. So this first part has to go like this. Same thing with the second part. Second part in between these two asymptotes. So again, looks kind of like what we did when we did rational functions. Okay, and this is what cosecant looks like. Now again, relating it back to its sine wave, so if I put in my 5 key points for sine, just like I did for tangent and cotangent, you can kind of see what's happening here. So there's a sine wave that actually cosecant is derived from. Now, notice, again, kind of like with tangent and sine, where tangent had zeros, sine had zeros, right? And cosecant, where sine has its zeros, that's where cosecant has its asymptotes. So wherever sine is 0, cosecant has asymptotes. Then where the maximums and minimums of sine are here and here, those are still maximums and minimums for cosecant. The only difference is they're reversed. Here at pi over 2, where sine had a maximum, cosecant has kind of like what we call a relative minimum. And here at 3 pi over 2, where sine had its minimum, that's what we call a relative maximum here in this part. Okay? But this is what cosecant looks like. And again, when I go to graph cosecant with transformations, I don't actually start with the parent function of cosecant. I start with sine, graph sine, what it would look like, and then from that graph, I create my cosecant. Because all I have to do is go to where my center line is, these points on my center line, and put in the asymptotes, and then find these points, my maximums and minimums, and that's where I put the curve's bottoms. And it becomes really, really simple. Much easier than trying to sit there and graph and transform cosecant.